See, very important theorem in digital systems or Boolean algebra. Always we'll talk about the De Morgan's theorem, right? So, which is very useful and essential theorem in the digital systems, which is De Morgan's theorem. So, what it will have two theorems. The first De Morgan's theorem is, if I take the logical OR with complement, so I will get individual complements with the multiplication, right? Logical multiplication. The second one is opposite, that is, if I take A into B whole bar, and I will get individual complements but additive operation, right? Logical. So A plus B whole bar means we can represent A bar into B bar, or AB whole bar means A bar plus B bar, or we can say, if it is X plus Y whole bar means X bar into Y bar, then XY whole bar means X bar plus Y bar. These two theorems, the De Morgan's theorems, are very, very helpful when we do when you want to find some complements of a given logical expression, or when you want to minimize the expressions also, right? So that will be very helpful, but we need to see first how it will be equal, right? The proofs we will see. So I will go for the first one or second one. You do on the next one. It's very simple. Just follow the procedure like this. So we're having two variables, right? If I take A and B, so whenever in Boolean algebra, whenever we are having variables, two variables, we'll get combinations, 4 combinations. That is 2 power n combinations. So if variables are n, so I'll get 2 power n combinations. 2 means 4, 3 means 8 combinations, and so on, right? So 2 power n combinations. N is variables, right? Now the first combination is 0 0 0 1 1 0 1 1, right? Now when we want to prove this first one, what we need to do first I will make the OR operation. Then once we know this value, then we can easily complement. Then to make this one, so first we have to make A bar, then B bar, then multiplication of these two, A bar into B bar. Yes or no? If this column and this column is equal, then the first law is verified. So what is our operation? We know the axiom side. 0 plus 0 means 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1 is also 1 in Boolean algebra. Now if I take the complement of this, that is also we know. When we just take complement of 0, I will get 1. 1 complement B means 0. Again 0, again 0. So this is over the RHS. So this is the right hand side, right? Now to find the left hand side, sorry, this is the left hand side, right? LHS. Now to find the RHS, so what we need to do? A bar. So what is A here? It is A. A is 0. So 0 means 1. Again 0 means 1. 1 means 0. 1 means 0. Now what is a B bar? So B is here. So 0 means 1. 1 means 0. Again 1, 0. What we need to do now? Multiplication of A bar into B bar. So 1 into 1, 1. 1 into 0, 0. 0 into 1, 0. 0, 0. Now see, this is the RHS. Both are equal or not? See, 1 0 0, 1 0 0. So these two are equal. So the first theorem, De Morgan's law, is verified. Our theorem, A plus B whole bar is equal to A bar into B bar. Similarly, we can verify the second theorem also. First find the multiplication A into B, then take invert, that is LHS. Then to find the RHS, A bar, similarly see A bar, B bar, then addition, right? Logical OR operation. So 1 plus 1, 1 only, 1 plus 0, 1, 0 plus 1, 1, and so on, right? That you do on everyone, right? It will be anyway, it should be verified. So this is the De Morgan's theorem, right? So remember always A plus B whole bar is A bar into B bar, and opposite AB whole bar means A bar plus B bar. Then next we will discuss one more theorem. So using this theorem, without mentioning this theorem name, so in the GATE exam they ask so many times this question, right? So it may be like XYZ variables or ABC variables, right? What is this theorem name is? Consensus theorem or included factor theorem. So to prove this theorem, so we need to include some factors. So that's why it is called included factor theorem. So without mentioning this theorem name, they have given so many times this question. So you can verify, check, right? Now, how to prove or etc. Suppose xy plus x bar into z plus yz is equal to, so we can eliminate this yz. Simply I can write xy plus x bar z, or ab plus a bar c plus bc is equal to, it is simply we can minimize it to ab plus a bar c. So that is this consensus theorem. How to prove this one? So we need to include factors, right? So whenever something like this, so I will take LHS, which is xy plus x bar z plus yz, right? Now how to prove this one is, we need to include the factors. That is how I am including, see, xy plus x bar z plus yz into, here see we are having 3 variables, right? So each term can have 3 variables. So if I need to add here, so suppose if I multiply it with 1 here, so yz into 1 means yz only. But how can I represent this 1 is, say y is there, z is there. What is missing here? X missing. So but I cannot directly add x, so I have to add x plus x bar. What is x plus x bar? Is nothing but 1. Then we are included is x, right? Now if I multiply, so I will get xy plus x bar z plus xyz plus x bar yz. Yes or no? Now from this, so how to eliminate the different values here? See, from this xyz and this xy, which is common? Xy is common. So if I take xy, so this will become 1 plus z. What is 1 plus z? 1 plus anything in Boolean algebra is 1 only. Now from these two, what is common? X bar into z common. So from these two, what is the common? X bar into z common. So x bar z, if I take common, this is 1 plus y. So 1 plus z is 1, 1 plus y is 1. So what is the value? Simply xy plus x bar z. Is this right? Right. Now you may get doubt, why we need to include here only? So it is not like that. We can include here also. How to do? In this, x is there, z is there, which is missing y. So I can make y plus y bar, right? And do like this. If you are able to minimize like this, then it's okay. If not, go for the next one. So here z is missing. So make z plus z bar. Now try to solve like this. If you are trying to minimize, then also that is also correct. If you are not finding the minimized expression, now go for this one. So one step by step we can go, but if you remember this one, we can directly apply where we need to add that one, right? Depending on the given expression. Similarly, you can prove this one. So in third one, we add a plus a bar, then take common, etc. So you can get this also. So you have to remember. Next, opposite, second one is, here xy is there, no? So take it as x plus y. Wherever plus is there, make multiply. Wherever multiply is there, make plus. So x plus y into x bar plus z into y plus z, which is also equal to x plus y into x bar plus z. Now it's very easy. If I take LHS and RHS separately, multiply, you will get the same. LHS is equal to RHS, something like this. See, x into x bar plus x into z plus x bar into y plus yz into y plus z. Yes or no? Then x into x bar is nothing but 0, right? So this will become xz plus, so this will become 0, x bar y plus yz into y plus z. Again multiply xz into y, so it will become xyz plus xz into z. So xz into z, z into z, again z only in linear algebra. In Boolean algebra, not linear algebra. Xz into z, so it will become xz only. Or I will write one more time, xz into z. Similarly, x bar y into y plus x bar y into z plus yz into y plus yz into z. So in Boolean algebra, z into z means z only. So this will become xyz plus xz plus, again y bar into y. So z into z, z, y bar into y, y. Y into y. So this will become x bar y plus x bar yz plus, again yz into y. So by associative law, what we can do? So I can make group any group. So y into y, again it will be y, so it will become yz. Again here also yz. What is yz plus yz? So both are same. You will get single yz, right? So this is xyz plus xz plus x bar y plus x bar yz plus again yz plus yz. Again, if you take here, see, yz plus x bar into y. If we take yz common, so I will take like this, xyz plus xz plus x bar y. If I take here yz common, this will become 1 plus x bar. 1 plus anything, 1 only. So it will become yz. Now from this yz and this one, I can take yz common, right? So this one, if I take yz common, this will become x plus 1. See here, I am writing directly 1 plus x bar means 1. So yz into x plus 1 from these two plus xz plus x bar y. So yz into x plus 1, again 1. So the final answer is yz plus xz plus x bar y. This is the LHS. Now we'll see the RHS. So x into x bar plus x into z plus x bar into y plus yz. So what is x into x bar? So 0. So what is the result? Xz plus x bar y plus yz. See this? Both are equal or not? See, xz is there. X bar y is there. Yz, so yz is there. So both are same, right? So this is this theorem, right? So we can include the factor also, but it is not necessary when it is like this. So just multiply, prove that LHS is equal to RHS. This is about some theorems in Boolean algebra. So we have discussed 3 theorems, and inside one theorem, so we'll have again two theorems, right? Now what you need to do is, so make a table of all the theorems or laws and axioms what we discussed so far in one page, and paste in your study room, and try to see always, because using these theorems and axioms, so we'll get at least one question pakka in GATE exam. There is no doubt at all. So we have to minimize the expressions, right? Now we'll see the important principle in Boolean algebra, that is called duality principle. So what it says, that is, the statement of duality principle is, every algebraic expression of Boolean algebra, so remember Boolean algebra only, remains valid. It's not same, it is valid. It will be valid if the operators and identity elements are interchanged. What are the operators? We'll have only and are only. So even though if interchange, and if I take the identity elements are also interchanged, what are the identity elements? Either 0 or 1 again. So we have to interchange. Even though if we interchange, that algebraic expression is valid, right? Now how to find the duality of that principle? Suppose if I know some expression, suppose something like this. If I know some f is equal to, the function f is equal to a plus bc, this is function, algebraic expression or Boolean function. Now how to find the dual of this one? So if the dual of an algebraic expression is desired, so we need to find the duality of this expression. What we need to do is, we simply interchange r and n. Wherever r is there, so we will replace by and. Wherever is and is there, we will replace by r, and replace ones by zeros and zeros by ones. If there is a 1 is there, then we have to replace with 0. If there is a 0, we have to replace with 1, right? Now why 1s and 0s? See, identity elements are interchanged. Apart from the operators, so what is the identity element of the R operation? It is 0. Yes or no? Identity element of the AND operation is 1. So we have to replace those 1s by zeros as well as zeros by 1s. Why we need to do this one? There is application of this duality principle. Now in many logical expressions, so we may ask to find the complement of any expression. So to find the complement of an algebraic expression, the duality principle is very helpful. I will go with some examples, so we will see what is the helpful of this duality concept. I will take this one. Suppose f is equal to a plus b. This is the function is equal to in terms of a plus b. This is a Boolean expression or a algebraic expression, right? Or logic function also, Boolean function. Now to find complement, so I can take f bar. So the complement will be replaced by f bar or simply fc also. Now how to find complement? I will take a plus b whole bar. We know the De Morgan's law. Yes or no? A plus b whole bar is nothing but a bar into b bar. For two variables, we can find like this directly. There is no need of duality principle, etc. Suppose some expression is like this: AB plus A bar C plus BC. Suppose if they ask find the complement, or suppose we need to find or we decide some complement of this function, what to do? If you go there with the standard procedures, it will take a lot of time. Now what we do is first to find dual. So dual representation FD. So duality of this one is, so we need to make, if there is a R, we have to replace with AND. Wherever there is a AND, so A into B means AND. So we have to replace with R. So A B will become A plus B in dual. So plus is there, so multiplication into again A bar into C, multiplication. So it will become A bar plus C, right? Then again R is there, so multiply, and this is AND operation, so it will become R operation. So this is the dual. Now after finding the dual, how to find the complement is replace each literal by its complement. That's it. So each literal make complement, right? That's it. So make complement. So A means it will become A bar plus B bar into A bar whole bar. So A bar whole bar means A plus C bar into B means B bar plus C bar. That's it. So this is the complement. But actually the normal procedure is we will take the whole bar, then we will apply the De Morgan's law and so on, right? So the complement, to find the complement, the duality principle is very helpful. If there is a very big expression to find the complement of that function, so it's very easy to find. Now for the same logic function, we'll try to find the complement by the standard procedure. So what we'll do, so what is the FCR, the complement, or F bar, right? So either one of the notation we can use. So what we need to do, this is the total function. So what we'll do is AB plus A bar C plus BC whole bar. Now how it is looking like? It is looking like De Morgan's theorem. So what is the De Morgan's theorem says? If A plus B whole bar is A, so you can replace A bar into B bar. This is not only applicable for only two variables, it can be applicable for multiple variables, right? So suppose A plus B plus C whole bar is there, then it will become A bar into B bar into C bar. If D is there, D bar and so on. So this is the one De Morgan's theorem. So according to this, I can make it as, suppose this is, I assume as some X, this is Y, and this is Z. So X bar, that is AB bar into Y bar, or that is A bar C bar into BC bar. Yes or no? This whole term I will assume as some A, B and C. So A bar plus into B bar into C bar. Now AB whole bar, again one more De Morgan's theorem we know, that is AB whole bar means it will be A bar plus B bar. So what it will become? So A bar plus B bar into A bar whole bar plus C bar into B bar plus C bar. So what is this? A bar plus B bar into A bar whole bar, which is A plus C bar into B bar plus C bar. See this? See, to find the complement, so what we have done, so we applied 2 times the De Morgan's theorem here, right? But whereas in when we use duality principle, so what we see, first we apply the dual principle, that is making AND replaced by R and R replaced by and each literal I need to make the complement. So you see this one and this one as it is, right? So that is the application of this duality principle. So when there are some questions given and they ask the find the complement. If you use this procedures, you will get in within a half minute or 15 seconds, etc. But if you go by this procedure, so sometimes you may go wrong also, right? By applying this De Morgan's theorem. Suppose in place of A plus B whole bar, if you substitute A bar plus B bar, that means gone. So it will take some more time, right? So that is the application of this duality principle, right? Now we'll see what is a Boolean function or logic function. So what is the definition of this Boolean function? Is a Boolean function described by an algebraic expression consists of binary variables, comma, the constant either 0 or 1, and the logic operation symbols. So this is some example of the logic expression or Boolean expression. So this A, B and C are the variables, binary variables, so it can only take either 0 or 1, and sometimes it may contain the constant values also. Suppose X is equal to 1 plus B, C, etc., right? Something which consists of these ones and zeros. So this is also Boolean expression, right? So anyway it will become always 1 because it is 1 plus anything is 1 only in Boolean algebra. Now, and what are the logic operations here? One is plus, and here there is a multiplication, or we can say AND operation and OR operation, right? So this is any logic expression or Boolean function. Now, what is the what you call definition, or what is the meaning of this Boolean expression is the function value f for a given value of the binary variable, that is A and B and C, the function value can be either 1 or 0. So depending on the input variables, generally we say here Boolean variables or the binary variables. So it can take either ones and zeros, and it will provide the corresponding the logical value at the output. So this function value can be either 1 or 0 depending on these variables, right? So that is the logical expression or Boolean expression, right? Now these Boolean functions or expressions, we can form a truth table or functional table, something like this. A Boolean function can be represented in a truth table, right? So whatever he says in this expression, so depending on these values, we'll have the combinations in the truth table or functional table. So for n variables, right? So what are the combinations we'll get? The combinations are row combinations. Row combinations will be 2 power n. Suppose if n is equal to 3, because we are having A, B and C. So for n is equal to 3, so from how many combinations you will get? 2 power 3, which is 8 combinations. So if I make a truth table, so A, B and C, right? So what is this? So combinations means 8. So from 0 to how many? Maximum how much decimal value I can make? 0 to 7, because 0 0 0 means 0, but 1 1 1 means 7. So that is 0 to 2 power n minus 1, right? This is the range I can say, right? 0 to 2 power n minus 1. Now combinations I can make 0 0 1 0 0 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 is the last one, right, which is 7, right? This is 2 power n minus 1. Now the function value is, what is the value? A plus B into C. Now what we need to do first? B into C. So what is B into C? Is nothing but 0. So plus 0. So we will get 0. The function value is now 0. Next 0 plus, again B is 0. So 0 into 1, 0 only. So we will get 0 only. Again C, 0 plus 0 into 1, 0. 0 plus 1 into 1. So we will get function value is 1. Next see A plus, A is for this all 4 combinations, A is 1. So 1 plus anything will get 1 only. So this is the truth table of the given logic function or Boolean function, right? Once we know the either the functional table or truth table, and we can make the Boolean expression also from the given truth table. Now once we know the expression, then we can implement using the gates. Anyway, first we need to discuss about the gates, then we can implement using the gates, right? So this is a Boolean function.